Hello, I'm Spiros Miselis. I will be presenting full rates of exercise throughout the year for IB exams, and I hope it helps your case. Hello again. Let's continue with the unit solutions. Solution is an homogeneous mixture. To fully describe a solution, we need its qualitative and quantitative composition. Let's know qualitative composition of solution. A solution has the components solved and solute. Aqueous solution the solvent is water. Water is the most usual solvent. Example. If we have a solution, we must know what's the components. Aqueous solution of sulfuric acid has the components solvent is water and solute is sulfuric acid. It's very important to know the components of a solution. To fully describe, we have to know the quantitative composition of solution. To describe the quantitative composition of a solution, we usually use the molar concentration or molarity the molar concentration of a solution is defined as amount in mole of solute dissolved in 1 dmet to the cube of solution. We use the formula the number concentration is equal with the number of mole divided with the volume of the solution. So we have mole and dmet to the cube for the volume, or mole per liter. Example. Aqueous solution of sodium chloride concentration equal with 2 mole dmet to -3, or concentration is equal to m, or means 1 dmet to the cube solution contains 2 mole solute sodium chloride. This means the concentration of a solution. If we know the molar concentration and the volume, V dmet to the cube of the solution, we can find the number of mole of solute using the formula the number of mole is equal with the molar concentration times the volume of solution. We have the number of mole of solute, the molar concentration, mole dmet to -3, and volume in dmet to the cube. Example. Calculate the mole of solute in 0.0 4 dmet to the cube of solution hydrochloride molar concentration equal 0.2 mol dmet to -3. Let's see the solution. We use the formula who gives the number of mole of solute. So we have the number of mole of hydrochloride is equal with the concentration of the solution times the volume of solution. So we have and the result is 0.08 mole. This is the number of mole of solute. Notes. The concentration of a solution can be expressed mass per unit volume. Grammars dmet to -3. Example. Solution of sodium chloride has concentration 4.2 grammars dmet to -3 means 1 dmet to the cube solution contains 4.2 grammars solute sodium chloride. Also we have parts per million for very dilute solutions. Concentration in ppm is equal with mass of solute times 10 to 6 divided with the mass of solution. Example. Ambient air in a city contains 0.252 ppm nitrogen oxide. Means if we have 10 to the 6 grams of air, contains 0.452 grams of nitrogen oxide. Let's see some examples about problems we find in solutions. First example. In an experiment, we need 100 centimeters to the cube of 0.1 mole Dmetz to -3 solution of sodium chloride. Explain how it is prepared. Let's see the solution. We use the formula. The number of mole is equal with molar concentration times the volume of solution. So we have to find Dmet for the volume, Dmet to the cube. So we have 0.01 mole of sodium chloride. We must find the grams of sodium chloride, so we need to find MR. And we have find 58.44. So the mass of solute is the number of mole times the molar mass, and we have 0.5844 grams. So we have to add the mass we find of sodium chloride to 100 centimeters to the cube volumetric flask with distilled water and make up to the mark with distilled water. Let's see example 2. Dissolved 1.24 gram of potassium carbonate to 100 centimeters to the cube volumetric flask with distilled water and make up to the mark with distilled water. Calculate the grams dimet to -3 and mole dimet to -3, concentration of the solution. Let's see the solution. We have to use the formula. Concentration, molar concentration is mass divided with the volume. So we have the mass divided with the volume in dimet to the cube. So we have to convert centimeter to the cube to dimet to the cube. And we find 12.4 grams dimet to -3. So we have to find the MR of potassium carbonate. Is equal 138.21. So we have to use the formula and to convert the grams in mole. So we have to divide the grams with molar mass. And the result is 0.09 mole dimet to -3. Let's see the third example. Dissolve in distilled water 4.25 grams of solid magnesium bromide and obtain 250 centimeters to the cube of solution. Calculate the molarity of the bromide ions. Let's see the solution. The concentration of magnesium bromide is equal with the number of mole of solute divided with the volume of solution. We must find MR for magnesium bromide. $184.11. So we find the number of mole of magnesium bromide, the number of grams divided with molar mass, and we have 0.023 mole of magnesium bromide. So the concentration, molar concentration is we have to convert the volume in dm to the cube. So we have the molar concentration 0.092 mole dm to minus 3. The magnesium bromide is ionic compound and in water gives ions according the chemical equation we call dissociation reaction, which is the solid magnesium bromide gives magnesium ions and bromide ions. So we have 1 mole of magnesium bromide gives 2 mole of bromide ions. We have 0.092 mole of magnesium bromide and gives bemol. So we have the rate and we find 0, 100.184 mole of bromide ions. So the concentration of bromide ions are equal with 0.184 mole dimed to -3. Remember, an ionic compound, when found in water, gives ions to the solution. These are dissociation reaction. Let's see some examples. Sodium chloride gives the ions, and we have also some examples. Potassium sulfate, and magnesium phosphate. Let's see the dilution of solution. In dilution, a poor solvent is added to a solution with the result that the concentration of the solution is reduced. So we have to add a VDM to the cube of solvent to initial solution, and we take a final solution. In dilution, apply that the mole of solute remain constant. That means the number of mole of solute in first solution, the initial solution, is equal with the number of solute in final solution. So we have the number of mole is equal with the concentration of initial solution times the volume of initial solution is equal with the number of mole which is equal with the concentration of final solution times the volume of final solution. And the volume of final solution is equal with the volume of initial solution plus the volume of solvent. And you must say that dilution of solution reduce the concentration. This is very important because in a laboratory we have a solution with high concentration. Let's see an example. "40 centimeters to the cube solution of hydrochloric acid of concentration 0.5 mol dimet to -3 dilute to the volume of 200 centimeters to the cube. Calculate the concentration of final solution." Let's see the solution. In dilution, we have the relationship that the number of the solute, the number of mole of the solute remain constant, so we have the relationship, and we have to convert centimeter to the cube in dimet to the cube. So the concentration of the final solution is equal and the concentration is equal with 0.1 mol dimet to -3. We see that the concentration has decreased. Let's see the titrations. Titration is the experimental procedure to find the volume of solutions that react exactly with each other. We have a barrette and a conical flask. In the conical flask, we have 200 centimeters to the cube of solution of hydrochloric acid, and in barrette we have a standard solution of sodium hydroxide, concentration 0.1 mol dmet to -3. We have the initial volume, and let's see the procedure. Slowly add an amount of sodium hydroxide standard solution until it reacts completely with the amount of hydrochloride in the conical flask. An indicator is often required to determine the endpoint. We call equivalent point, in which have a change of the color of the solution in the conical flask. We see later more details for titration. At least (40 centimeters to the cube) solution of sodium hydroxide required. This is, we can see it if we mark the initial volume and the end volume. The reaction takes place and the titration is and we have 1 mol reacts with 1 mol, So the number of hydrochloride and the number of sodium hydroxide are reacted. So we have the rate and we find that the number of mole of hydrochloride is equal with number of mole of sodium hydroxide. And we have the relationship so we have to convert the dimet in the cube in the centimeter in the cube to dimet in the cube. And we have the concentration and is equal with 0.02 mole dimet to -3. Let's see a second example. For 0.0036 grammar of calcium carbonate reacted with excess of hydrochloric acid of 0.2 mole dimet to -3 when the reaction was complete, the excess of hydrochloric acid required 50 centimeters to the cube of solution of sodium hydroxide, 0.1 mole dimet to -3 to react to reach the equivalence point in titration. Calculate the volume of hydrochloric acid. Let's see the solution. We write the first reaction. And we have that 1 mole of calcium carbonate reacts with 2 moles hydrochloride. We have to find MR of calcium carbonate is equal with 100.09, so we can find the number of mole of the mass of calcium carbonate. So the number of grammars are divided with molar mass, and we find that we have 0.04 mole of calcium carbonate. So we can find the mole of hydrochloride which react. So we have 1 mole of calcium carbonate reacts with 2 moles hydrochloride, and the 0.04 mole of calcium carbonate with bemol hydrochloride. So we have the rate, and we find that 0.08 mole hydrochloride are required. Let's see the second reaction is the reaction in titration, and we have and 1 mole reacts with 1 mole, and we must find the mole of sodium hydroxide is equal with the concentration of the solution times the volume of the solution in dmet to the cube. So the number of mole is 5 times 10 to minus 3 mole. And now we can find the mole of hydrochloride. 1 mole reacts with 1 mole. So same mole hydrochloride reacts with the number of mole of sodium hydroxide, and we have the rate. And we find that reacts 5 times 10 to minus 3 mole hydrochloride. So we calculate the total mole of hydrochloride is equal zero point 0.085 mole hydrochloride. So we can find now the volume of the solution, and we have so the volume of the solution is equal so we have 0.425 Tmet to the cube. This is the last example in chapter 1, and I hope to help you, and we follow with chapter 2. Thanks for listening, and more IB chemistry videos to come. If you like the video, and you can support me on Patreon. Thank you.